TIG welding, or inert gas tungsten arc welding, is the preferred fusion welding method for aluminium, utilizing an arc between a tungsten electrode and the workpiece in an inert gas atmosphere, R-He or R-He mixture. Depending on the weld preparation and the workpiece thickness, it is possible to work with or without a filler. The welding power source delivers direct or alternating current. A major difference between the welding of steel and the TIG welding of aluminium is the adhering oxide film on the aluminium surface, which influences the welding behavior and has to be concerned. The oxide film can be removed by varying the current type or polarity, or also through the use of suitable inert gases. TIG welding equipment consists of the following components: source of welding current, torch unit with hose packet, gas cylinders with pressure-reducing valve and flow meter. Modern welding power sources can deliver both direct and alternating current. Depending on the magnitude of thermal stressing, the torches can be air or water-cooled. The water cooling cools both torch and current cable. In the region of the gas nozzle and the arc burning location, the cooling action is provided by the inert gas. Torches of different configurations are necessary to allow for the different accessibilities of the weld seams. Welding at locations which are difficult to access can be made easier by using the short or elongated torch forms. The torch design and size also depend on the type of cooling, air, or water cooled. The type of shielding gas used has a major influence on the weld quality. The required purity of the gases must be guaranteed. It is most important that the limiting value for humidity is not exceeded. The pressure of the gas contained in cylinders is reduced by pressure-reducing valves. The amount of gas flowing in L-min is controlled via a regulating valve and indicated by the flow meter. Flow meters, which can be fixed directly to the torch nozzle, have proved to be very practical. This shows the amount of gas actually passing through the torch in L-min. The amount of shielding gas required depends on the material used and its thickness. The gas nozzle diameter has to be optimized for the electrode diameter used. Because of its lower density, the amount of argon required is larger than the helium amount needed. Now about tungsten electrodes for TIG welding. Oxide additions. Oxides of thorium, zircon, lanthan, and cere to the tungsten electrode reduce the electron emission energy. This improves the arc stability, electrode life, current loading capacity, and arc igniting properties. Depending on the torch manipulation and the filler metal introduction, one refers to manual welding. Torch and filler metal are manipulated by hand, as in gas welding, or fully mechanized welding. Torch and filler metal are manipulated mechanically. Thanks for watching.